Let's look at question 41. First, missing positive. This question gives us an unsorted integer array numbers. Return the smallest missing positive integer. They require the algorithm, the time complexity should run in big O n and used constant extra space. So you cannot use too much space like big O n square. What it means for the smallest missing positive? So first, this one will positive integer. So they start from 1 and find the smallest. So they give 1 to 0. So we only need to care about 1, 2. What is followed by the 1, 2 is 3. So we should return 3. And this example, 1, 3, 4, minus 1, negative 1, and 1. So we ignore the minus 1. So what is the smallest missing integer is 2. So they also give the constraints, the total numbers lines, and give the value range for the numbers. So let's analyze this question. If, let me see, if the number range is small, for example, they from from 1 to 100. So what our solution is we set up from index 0 to index 100. We have an array, and if we see any number, we set up this one is 1. The initial value will be the 0, right? So if we have input numbers, the value is ranges from the 0 to 100. So we have other space. So we put we read one value and set up his flag. Then we scan this one and find what is the first we meet. The value is 0, 1. So we find out this one is the smallest positive. However, each side, the range will be the cross all the 32-bit integer. So this is impossible. However, let us think this one. This one. So this side, the number size is from 1 to this one. I think is 100K, right? So if from the 100K, let us think this question. If the lines, this number, right? His lines is n. So what is the possible value for the smallest value? So this value should be from 1 to n plus 1, right? Why? So if the length is n, we think about we put a number from 1, 2, 3, 4, 5. And then the last one is n, right? Because this is a length is n, right? So what is in this case, what is the smallest missing positive value is n plus 1. If we have something in negative, for example, here, we miss some value, right? So the result will be from 1 to n plus 1 is smaller than n plus 1. If you have any value in here is small, more than 0, or the duplicate value, right? Okay, so in that case, we can do one thing to the numbers. We scan from the left to right. If the value is less than or equal to the 0, we change those value to 1 because they're same thing, right? So first we scan this whole thing. Then in that one, in the same time, we will detect is any value equal to 1. If it's equal to, after we scan the whole thing, if no value equal to 1, we directly return 1 because the 1 is the smallest missing positive, because in the whole string we did not find the 1. And then we change everything less than 1 is to the 1. Also, we need to change every number is more than n to 1, right? Because if it is more than n, we don't need to care about it, right? Because of the result should be from the 1 to n plus 1. Okay, let us do it. So first thing is set up Berlin. Find one is false, and for beginning numbers, so if numbers minus we do this transform. Okay, after we done this one, if find 1, we cannot find the 1, so we directly return 1. So we are done, right? Otherwise, right now we have all the possible value in that one. So here, if we do not want to save the space, very easy way to do this one. So flags, new int, n plus 1 because we have n value, right? Then for I from the numbers, actually Java will initialize the array to 0. So flags I, because I is from 1 to n, right, will become the 1. And then we scan from the first element. We need to know 0, right? And less than flags here should be this one. Flags and so if numbers if flag I1 is 0, so we find it, right? If everything set, we should return n plus 1, right? So let us see the code. Verse line, we have flags. Okay. Yeah, we are done for the code. However, here is the thing: we have the extra space. So extra space is not good, right? Actually, we can reuse the space, number space. So how to reuse? So we go through each one from the number. Here, we do not need the create the new space. So we do the same thing from here. Right. We reuse these numbers, but how to reuse? So if numbers I1, his value is n, right? What we need to do is we will set up this value to some flag. Okay. So how to set up flag? We can, in the one hand, we want to reuse this space, and the second hand, we do not want to lose the information. Remember, everything in this array is positive, so we can use the negative to save it. So value will be the it doesn't matter its value, right? Is positive or we use this after use this function. Okay. If we equal n, so we set up numbers 0, because if we use n, it's go out of space, and in this array we do not have the value 0. So this one will be the minus v. Otherwise, numbers v in this one will be the 0 minus mass abs. In this position, we right? We let its value become the negative. So after we done everything, we go through this one and find here is no, this one, right? Okay. So don't forget n. So if numbers 0 is more than this one, this means n is not set up. So return n, else return n plus 1. So we reuse this space, so we do not need to create a new space. Okay. Okay, numbers. Oh, here. So let me try, can we have a, because this is not stable, right? Let me rerun one time. Yeah, sometimes it's okay, sometimes faster, sometimes slow. Okay, thank you for watching the video. We finished question, and in the time complexity is big O n, and space we don't use any extra space, so it's big O1. Bye.